Hey, mean value theorem. All right, let's start. All right, let's start. What is the mean value theorem? Did you review it? Mean value theorem is. So let's recall.
Mean value theorem is the function is continuous and must be
Right. So you need two things. You need two conditions, right? First is the function needs to be continuous. It's continuous.
And it must be differential.
Continuous on where?
On AB.
On AB is open parenthesis or bracket. Close. So that means they need to be continuous on close and bounded. If you hear the word close and bound, did you hear that before? Have you heard that before? Close and bounded? Yeah, so that's what they say. Close and bounded. It needs to be close, it needs to be bounded. That means it needs to have the maximum and minimum. Okay? And the second condition is the function needs to be differentiable. Yeah. Two things need to happen before you can apply the MVT. If they don't, then you cannot use the MVT. It doesn't apply. Sometimes they ask you, can MVT apply for this? That's what we're going to do today. We want to delve deeper in the MVT. Differentiable. On where?
Open AB.
Open AB. One close bound, one open. Then there exists one value. Okay. Then what is this? Do you remember this symbol?
Wait.
Hold on, mister. Hold on, let me check my
I know it.
Belong to.
Yeah.
No,
Wait, no?
it belong to it like this.
Oh. Do you write that down?
Then there exists. This is there exists.
There exists.
Oh yeah.
There exists. Okay, that's the map symbol. There exists.
Mr. What's there exist at least? What is there exist at least?
There exists unique. There exists unique.
Oh, okay.
Yeah. So there exists only one. Then they put a exclamation. There exists only one. But only there exists, then we're gonna put here. So like there exists x in R. Something like this. There exists a value x that belongs to the real integer, real number. So that's the way you do it. Now, you know math, they don't like to write a lot. They just like to do math symbol. Okay? There exists a value c in where?
In closed A and B.
Close A and B. Very good. It's C. There exists a value c such that what? The derivative at that point, the slope at that point, that's the concept of the MVT.
F.
Belong in okay? Such that what?
That's where you put the equation.
What is the average rate of change for A and B? How do you find it? FB minus FA over B minus A. Okay? So literally what the mean value theorem says is that for any point between this interval, they guarantee you that the tangent line of that point, there's just one point that the tangent line will be the same, the parallel to the slope of the whole A and B. So if you draw the line, so that's something like this. So that you can, let's say you have A and B, okay? The function, it must be continuous, so I'm gonna do something maybe like this, okay? So what is the mean value theorem said? This is the concept. If you understand this, it makes more sense to you when you do it. This is F, F what? FB. This is F, FA. So what's good? I have A, I have B. This is the function, this is the output of the FA. And this is the output of the FB. Yeah? Now, the mean value theorem says that there's a value C. Oh, let's find the slope of the AB first. What is the slope of the AB? What is the slope, average reaction of AB? Like this, correct?
Yeah.
Right? That's the slope. This line right here is the FB minus FA over B minus A. Rise over run. Actually, this is the rise over run. rise, the different number rise over different number run. See? They're all connected. This is R01, right? Rise over run right here. Rise over run. The slope. Kind of like slope. Yeah? This is just the context. Now, the mean value theorem, they say that there exists at least one value C between A and B. So like right here, C. So that the derivative, the slope at the C, will parallel to this, like this. That's what they're saying. Yeah? And this is the FC. That's what they're saying. That's it. That's what they're saying. Yeah.
So it's saying, Mister, that the derivative of C will be the same as the slope of
Exactly.
F.
Yes, that's what they're saying. That's the concept of MVT. So if you don't understand what does it mean, then you can memorize more and you can apply it to the problem. Okay, let me say it again. You give me thumbs up if you understand MVT now, or you? Yeah. Like how we apply it, right? Yeah.
Yeah, I understand. It's just like seeing it like this makes me lose my mind.
Why? I thought I was waiting for like a constant visual. Oh, look like this is gonna make more sense.
I understand what you mean. Like I understand. I think for me it's always when I see just continuous and differentiable, it makes sense.
Oh, because this two thing is kind of vague, right? You don't know what's going on.
That's why I'm like,
Oh, okay. Continuous mean you can draw it without lifting up the pen, right? That's continuous. Differentiable mean you can find a derivative. That's it. Yeah. When, in what case it's not differentiable? When you take the derivative and you have like bottom, zero bottom, that's that exists, right? That's not differentiable. Differentiable just means that you can find the derivative. That's it. The derivative exists or the limit exists. You can think like this. Yeah. Yeah. Okay. So again, mean value theorem just say that between the interval, there must exist one point so that the slope at that point is parallel with the slope of the whole interval you just chose. Okay, that's here. A, B here. The slope is this. I know that between them there must exist a point C so that the slope, the tangent line will be also parallel to this. The derivative of C must be the same as the slope of AB. That's what the MVT said. Okay. Now let me give you the problem that we applied to MVT. Because this is actually on the AP classroom. It's unit 5. We kind of like changing a little bit because to improvise. Remember? So sample 1. Any questions?
To verify that or prove that MVT works, we have to prove that it's continuous and differentiable. And then we just have to find f prime of C. Right? That's all we have to do. And then to do
Maybe next time I can just take a picture of my note and then show on the board so we don't need to waste time of writing it. First, you have 0 and 2, right? 0 and 2. And the function here is kind of parabola or something, but you're gonna see something like this. Something like this, to make it up, okay? And then you're gonna find the slope of AB. You got it? 2. So this is the slope of AB. Right? So you got this one is it's 2, correct? Now you need to find the point C somewhere around here. So that the tangent of that point is also 2.
Yeah.
But how do you find the tangent line? You take the derivative. Do you agree?
Yeah.
Then what is the derivative of this?
2x.
Right. So y prime equals to 2x minus 2. And I want to find the tangent line of C. What do I need to do? I just plug in the x by C. That's it. So now I have 2C minus C. Thus, this is the tangent line of any point C here, right? And this one needs to be equal to 2. That's it. And you can solve for C, right? This one needs to be equal to the slope of the AB, which means they need to be equal to 2, right? From here. And then can you solve C from here? C is?
Wait, Mister, where did you get the 2C minus 2 from? Oh, you just plugged in?
I take a derivative.
Yes.
And then I remember, you need to understand what does it mean. What does this mean? When you take a derivative, what does it mean?
You're
That
finding
means it's
you're finding a tangent line.
Here? Why people say 2, I don't know. Okay, let's tell me. I've heard you all say 2, and I thought this was going to correct. Okay. F2, what is F2? F2, you plug it in here. 0 squared is 4. 4 minus 4 is 0. It's 0. Right? So this is 0 minus F0. It's also 0. Oh, yeah, it should be 0. How did you get 2? How did you get 2?
Well, then do the bottom.
2. 0 divide everything is 0. I don't even need to do the bottom. Right? How did you get 2? So this is 0. It is 0, not 2. Yeah, thank you for catching it. Because everybody said 2, I thought it's 2. Okay, so it's 0. Then C equal to 1. Good. Question. Ask me. You need to understand what is this derivative. What does the derivative mean?
The slope of C.
The slope of all the tangent line. Whenever you have a function and you take a derivative, that is the slope of all the tangent line on the point, on the graph. So all the point on the graph will have the tangent line this. Every tangent line. So now if I want to find the tangent line at specific point C, I just need to plug in C here. Yeah? Make sense? So now I think you go with this, right? You go with the finding the C. Now, did you verify it? You need to have some reasoning to verify that MVT can apply. How do you verify it?
You plug it back in.
No, you verify. You need to have 2 conditions. Question. So here you need to prove that these 2 satisfy before we can apply the MVT. Is this function continuous? Yes. Why? All right, write down. I don't know if you, huh? Had to pass the point?
It's continuous, so at one point it has to.
Write this one down. I think you all need this sentence. All polynomial are continuous. That's the fact. Okay. All polynomial continuous. What is polynomial? It's multiple term. Do you have can we have a rational function? No. Okay. What is a poly? What does a poly mean? Multi, right? So it's going to be look like this. Something like this. It look complicated, but what does it mean is if you have something to the x to the power something and it's going down, like x10, x5, x2, but they all need to be like all x, no division, no complicated power. Like give me some sample polynomial.
X squared plus 4.
Yeah, any linear function, quadratic function, cubic function. Yeah, they're all polynomial. All right. Is this polynomial? No. Okay. No fraction. That's called rational function. Polynomial on the top and polynomial on the bottom. Is it polynomial?
Yes.
Yes or no?
Yes.
No? Is it polynomial?
Wait, I'm gonna say
No, because there's no combination.
Who say yo? Who say no? All right, who say yes? Who's just staring at me? You did you raise your hand too? This is yes. Because x to the power 0. Do you agree? Yeah?
Yes.
As long as you have this, as long as you have x, then this is polynomial, right?
it's fine. No, it's fine.
Is it polynomial? Is it polynomial?
No.
No. Is it polynomial? No. They only need to be this form. Coefficient with the x and power, coefficient with x and power, no matter what power you have. But it needs to be in this. Then they all continuous. They all continuous. Okay? That's very powerful fact. You don't need to prove it. Oh, I see this. This is polynomial. They're continuous automatically. You don't need to prove it. How do you prove if the function continuous? When continuous, that means they have no, they have limits. Yeah. Yeah, that's one. That's one. Do you remember the continuity of the function?
No, I don't.
Discontinuity is you have removable discontinuity, right? Some discontinuity, right? So how do you prove it's a function continuous? Karen, can you help us? When the limit of the left is the same as the continuous of the right?
Yes.
Yeah?
Yeah.
And also,
Also.
is that equal to the middle too?
Oh,
Because you cannot lift the pen, remember? So limit on the left equal to limit on the right and equal to limit at that point. Because they need to be continuously, right? You cannot lift the pen. They need to be continuous, yeah? If they're not polynomial, then you need to use in that definition to prove if they're continuous, okay? So how about second condition, differentiable? Again, how do you prove it a function differentiable? Yeah, Karen.
Yeah, actually, I don't know. Yeah, I know, but I don't know.
I know that I don't know. Okay, that's a good one. So the shortcut way, yes, the shortcut way is you can take the derivative. If you can take the derivative, that means the derivative exists. That means they differentiable. If they're not, then you need to prove it. Okay?
What's not the short?
Huh? Differentiable is when if they're not, then you need to use in definition. What is the definition of derivative? Limits x go to 0. You remember? Yeah, that's one. Yeah, h go to 0. X f of x plus h minus fx over h. Yeah, it's not complicated, but you know it, and it's on your note. Yeah. I will go with this first example. So this is the second part. Let's write the first part. The first part is just say this function is polynomial. That's why it's continuous. It's continuous. And then second condition, you say the derivative of this is 2x minus 2, which is assist. So it's differentiable. Okay? It is continuous because it is a polynomial. You need to say that. That's why they say verify. Okay? It is differentiable because we can take the derivative. The derivative exists. Or you're gonna use the definition. Derivative is limits of h go to 0, fx plus h minus fx over h. Or you can say this is assist. Yeah? Just plug it in x plus h into the whole thing here. It's long, but you don't need to. The shortcut is you say, oh, the derivative exists. Okay?
So how are we gonna write it down?
Okay, let's write down. So first condition, f of x is a polynomial. To be precise, what is this name? What is the name of the function? Oh, okay. Don't worry. What is the function? Him. Yeah, but yeah, the probably the shape, but what is the name? Function. I know, it's a function. What is the name of this? In fact, when the highest degree is 2? Quadratic function. It's a quadratic function. F is a polynomial, so it is continuous. Yeah, you can say one sentence like this. Second, assist. So it is differentiable.
Wait, who sings the "Don't Forget" or something like
Okay, you can just say that.
Who sings it?
This is quadratic, so correct graph should be like this.
Wouldn't it be like a penis?
Because there's no moving up and moving down, so it needs to be exactly also. So this is 0, this is 2. Oh, the slope for this is exactly 2 slope. And the point here, the point C.
Tell me what now.
C is 1. Because that's also give you the same slope. That's the picture. Yeah? Now this is the picture of the function. And at 0 to 2, the slope is the straight line. That's what the slope is. Oh, that's what the slope is. 0. The slope is 0. Okay, and this one, the slope is 0.
So this, no, it's
I like it. You
And
can
then he
hear
just
her.
runs them down.
No, but like actually somebody did
You got bad. No.
Huh? No, assemble 2. Same question, but different function.
For this one, I'm gonna try super
That's what you
I like this.
when it's repetitive.
The song, I heard it. It's pretty good. I don't know. I haven't heard.
Continuous is differentiable, yes or no?
Yes, someone yes.
Raise your hand, then I'm gonna count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 people say continuous means differentiable. Now, that means the rest say no, right? Now, differentiable is continuous. We say yes. No? Okay. All right.
He said no.
Oh, the answer is all the other way around.
What do you mean?
This is no and this is yes.
Really?
Yeah, let's. Yeah, I'm gonna explain. Okay.
Explain now.
Yeah. Yeah. Okay. Good. Yeah, I'm doing that. You don't let me talk. I'm gonna explain it. Continuous. Let's do this way first. This way first. Okay. Differentiable, automatically continuous. Maybe write down. We'll write down somewhere boxes so you can know. When a function is differentiable, they automatically continuous. Okay, they automatically continuous. Now you applied it and you understand it because everything connected. Everything, even the thing you learned in algebra 1, now they all make sense. They all connected. Okay. Why differentiable, automatically continuous? Differentiable means you can take derivative, correct?
That's true.
What is the definition of derivative? I just wrote it somewhere here, right? Derivative is limits of x go to 0, fx plus h minus fx over h, right? When they're differentiable, that means this exists. Do you agree? And when x go to 0, what happens? This means this will go to 0, right? So you have fx minus fx, which is 0, right? If this exists, and what does it mean when it goes to 0? If you plug any point, if you plug in any point like fc, then fc equal to the whole thing here equal to 0. That means fx equal to fc. The derivative fc equal to fx. I mean, what is the definition of continuous? The left equal to the right and equal to the middle, right? So this showing you that the derivative is actually at the point. So that means it's continuous. Okay, you don't need to understand it. Just remember differentiable, automatically continuous. Something to do with the formula, because when you have derivative, that means this whole thing here will go to the zero, and that means the top is zero. So that means f of x plus h equal to fc. This showing you that the limits of the left equal to the limit of the right and equal to the limit of the point. Okay? Now, is this true? When it's continuous, that means it's differentiable?
Well, apparently not. Apparently not.
Yes or no? Sometimes.
You told me to tell you.
So this is not all the time. Okay? In what way they fail? In what way it's continuous but it's not differentiable? Remember I told you what does it mean when a function differentiable? When you get derivative. And what does it mean for derivative?
That means it's like when.
I just told you like 50 minutes earlier. What does the derivative mean? Derivative mean, Isabel? Right, the slope, whenever you take the derivative, that means all the slope of the tangent will be in this form. Okay? This is the slope of the tangent line. Yeah? So, when it's differentiable, that means all the points must have a slope. No matter the slope is 0 or not, it still needs to accept the slope. So you need to find some function that is continuous but doesn't have a slope.
Is it when it like changes quickly? Like
Yeah, yes, exactly. When they have a curve or they have like in the turn like dramatically, like Isabel said. What is the basic function example for that? No, parabola is very smooth. Huh? Absolute value. This right here doesn't have slope. The slope only happens when they smooth like this, okay? Like this one they have slope, right? But if you make a sharp turn like this, there's no slope. So they fail right here. Okay? Is it continuous? Oh yeah, for sure, right? It's continuous. But is this differentiable? No, because there's no slope right here. Make sense? So differentiable automatically continuous based on the definition. But continuous doesn't mean differentiable all the time. For example, if you have some sharp turn like this, no. Yeah?
But Mr.
Yeah.
So it only doesn't count for that it's not differentiable just because of that one point right there.
Right. Differential means they need to have a slope of all the point. Right? If one point doesn't have slope, it's not differentiable. Yeah? But sometimes if you want to fix this, you just consider this part. Like 0 to 1, for example, or 1 to 2, because it's not 0. Then if you consider only this, then this part only is differentiable. That's why on the definition of the MVT, it needs to be differentiable on A and B. Right? So it depends. Let's say if your A is 1, your B is 2, then this is okay, right? Right? It's only not okay when you hit to this sharp turn. So yeah, so you need to understand what's going on, and you think that you will love it because everything now makes sense to you. Yeah? Yeah, question.
How do you find out when it has a sharp turn?
Based on the function they gave you. Based on the function. Yeah?
But most of the time it's short.
So like this function right here, x equal to y equal to absolute value of x. What did the sharp turn happen?
Huh?
Happen at 0.
No.
No slope at 0. Okay? Because for this one, if you want to take the derivative, you need to consider 2k sin equal to x equal to negative x. And it doesn't have slope at y equal to 0. Yeah? Okay, number 2. Is this function polynomial? No. This is like cube root. Okay? So, is it automatically not continuous? You don't know. You need to check. How did you do the continuous then? Like Granny just said earlier. The left equal to the right and equal to the point. For every point on the negative 8 and 8. This one have the power, the fraction, so it's not polynomial. Remember polynomial, all the power needs to be a beautiful number, a whole number. Okay? And no no fancy like this, no ln, no power complicated. Okay, so this is not polynomial, so you cannot conclude this is continuous. So how do you check if they are continuous?
So first you find out if it's differentiable by taking the derivative, and if it's differentiable, then
You can also do that if they're differentiable, then if they're differentiable, then it's continuous. But remember, what is the definition of the FVT? They difference. Can you see here? Okay, they different on
I may be able to.
open parenthesis, but they need to continuous on close and bound here. Do you see the difference? Like you need to check if they're also continuous on the bound, yeah, on the bounds, on the endpoints. So how do you check if they are continuous?
Plug it in.
you see the brackets and the parentheses.
You're gonna see if they have any hole, right? Because removable discontinuity is when you have some hole,
Yeah.
or if they jump, or it's a piecewise function. So you can one way you can use it, you can use a decimal to wrap this to see if they are continuous. Yeah, you can do that. But I think it's continuous. It is continuous. Okay. Cube root, there's no rejection. There's no rejection on the cube root, so it's still continuous. But is it differentiable? Check in derivative. Let's check in derivative. How do you check in derivative of this? What is the derivative of this?
2/3
Okay, so you have
1/3.
2/3 x to the power negative 1/3, right? And what does the negative 1/3 mean? That's mean negative mean you put it on the bottom here and to the power 1/3, right? 1/3 mean cube root, correct? Right? The power 1 inside, the bottom 3 is outside the cube root. Is it always as this? Always defined? Is it always defined? When is it undefined? When x is 0. Right? Now, you cannot conclude immediately this is not exist. You need to check if 0 is belong to the interval they're looking for. Is 0 in between the -8 and 8?
Yeah.
Oh, then this is not differentiable. You know what I mean? What if they're asking you, oh, check this one on 5 to 10? Then is it okay? Yeah. Well, okay. Remember, this function is not differentiable when x equal to 0. Right? But the interval they're asking you, for example, they're asking you from 5 to 10. Then is x equal to 0 matter? No, then it's still differentiable. You know what I mean? But this time they're asking you from -8 to 8. So when x equal to 0, does it matter? Oh yeah, because this is between here, right? Then is this function differentiable?
No.
On -8 and 8?
No.
No. So can we use the MVT? No. So you can say this function is not differentiable on -8 and 8. Therefore, MVT cannot apply. The MVT is not applicable. Make sense? Then you don't need to find C because it's not applicable.